This one ends up being our absolute favorite test. It is the ratio test. So what you're going to do is you're going to take the ratio of an plus 1 over an. Remember, an plus 1 is just the next term. If you take the ratio and the limit of those is less than 1, it converges. If it's greater than 1, it diverges. If it was equal to 1, the test fails. It usually was going to be a LCT. Now, we use ratio tests most of the time when we have e to the x and factorials and polynomials, when there's lots of different kind of stuff together. So on the first one, I just want to show you that if you try to do this first one, which we know is just p equals 1 harmonic diverges, and we try to look at that, you would get a limit equals 1. Same thing here. P equals 2, this one converges, but if I try to write that as the limit as n goes to infinity of 1 over an plus 1 squared over an squared, the degrees are going to be equal, and that's also going to be 1. So the bad thing about the ratio test is that there are some times you shouldn't use it. Basically, if LCT or if it was a straight up P series, then you shouldn't be using it. All right, so this one, again, what I see here is I've got a geometric that is decreasing, and I've got a polynomial that would cause it to increase. So it's really hard to predict what this is going to do. You'll get better at it at some point to be like, oh, this geometric goes faster, but that's not a test. So the first thing I do is write an, which is exactly this thing. Then we write an plus 1, which all you do is plug n plus 1 everywhere there's an n. We write the limit of an plus 1 over an. So I just substituted those things in there. But we hate complex fractions, so instead of dividing by this, I multiply by the reciprocal. Now, absolute values don't mean anything on here because there's nothing negative. So the next thing we go do is try to cancel anything we can. Is there geometric pieces you cancel? Is there factorials you can cancel? So we had a 5n on top, 5n plus 1 on bottom. So I have an extra 5 on bottom. I have n plus 1 threes on the bottom, n plus 2 threes on the top, so there's one extra 1 on the top. Now once you do that, and you got everything canceled, you're going to look at the degrees that are left. If there's no factorials anywhere in the problem, the degrees will be equal. If there was a factorial, that's going to be something different. All right, so here the degrees are equal, which means it's the ratio of the leading coefficients, which is less than 1, so it converges. And here I just wrote it concise so you can see it. Again, I think most of us can look at 4 and say, yeah, I think that converges because this exponential, this factorial is going to grow so much faster than that 4 to the n. But that's not a test. We got to actually have a test. So here, there's an plus 1. Take the limit of the ratio. Again, multiply by the reciprocal. At this point, I have an extra 4 on top. But here, I have n factorial and n plus 1 factorial. So remember, that would be n plus 1 times n factorial. So those n factorials canceled. I just have this n. So now my degrees are not equal. Notice there was a factorial in the beginning. As n goes to infinity, this goes to 0, which is definitely less than 1, so that it converges. Here, I see the factorial on top. I expect it to not converge. So here is an plus 1, an. And here, when you're replacing n, you replace it with n plus 1. So we're really writing 2 times the quantity n plus 1 factorial, which is really 2n plus 2 factorial. So be really careful on stuff like that. All right, so then we write the ratio of an plus 1 over an. Notice that this is the bigger one, so it's 2n plus 2 times 2n plus 1 times 2n factorial, and this 2n factorial is going to cancel this one right here. Notice that the degrees are not equal. In fact, I have degree 7 on the top, so 1, 2, 5 more, and I got 5 on the bottom. So the degree of top is bigger than the other, so it's going off to infinity, which is definitely bigger than 1. So it diverges by ratio. So same thing, just some more problems. Writing the ratio, an plus 1, multiply by 1 over an. You go through and cancel the exponential piece. We can cancel the factorial piece. But remember, if there's a factorial piece, it is going to not have the same degrees. So here, the degree of the top is 1, the degree of the bottom is 2. So that's going to be going to 0, which is less than infinity, which converges. If the factorial is on the bottom, it will converge. If the factorial is on top, it will diverge. But that is not a test. It's just a shortcut that you can do like on multiple choice. Same thing here. Looks kind of geometric, but it's not geometric, so I'm going to break it up. So I have an plus 1 over an. And we need this to be true. Now it said, what are the values of x for which this is true? Well, if I need this to be less than 1, that means I need x to either be bigger than 6 or less than negative 6. Same thing here. So what are the positive values of p for which these converge? Any p, doesn't matter. As long as the p's are equal, it will converge. Because the degrees are equal. Geometric on top, factorial on the bottom, converges. Factorial on top, not a factorial on the bottom, immediately diverges. And here, this is harmonic, but we bring this other one down, so this one's also going to converge. Again, just more ratio test. They're having you get to the limit and write more of it out. We know that this is true and that's equal to 6, so which of the following are true? Well, if these two are equal to 6, that means that an plus 1 over an. So I'm just going to look at each piece like the ratio test. So if I did an plus 1 over n plus 1 to the 7th, and then over an multiplied by the reciprocal, these degrees are equal. And I know this limit was 6, but I'm using the ratio test. 6 is not less than 1, so this one does not converge. If we have it written this way, again, an plus 1 over 7n plus 1. I write my 7 over here. Now these guys cancel and leave me with a 7 on the bottom. So on the top, we'd have 6. On the bottom, we'd have 7. And we know that is less than 1. So that's going to converge. Inconclusive. Ratio test is always inconclusive when it should have been a limit comparison test. This right here is either harmonic or a limit comparison test. This right here is a limit comparison test. Whenever it's a limit comparison test, the ratio test fails. I would compare this to 1 over n, which diverges. Factorial on top, diverges. Degrees are equal, so the limit of these is going to 1/4, so that would diverge by nth term test. So all of them diverge. And here's just matching up some of the different tests. The nth term test, that says that if the limit is not equal to 0, then it diverges, which is inconclusive for convergence. There you go. Geometric series says R's got to be less than 1 for it to converge. P series, P's got to be bigger than 1 for it to converge. Alternating series test, it's got to go to, the limit's got to go to 0 and it's got to be decreasing. Integral test, you need it positive, continuous, and decreasing. Then if the integral converges, the series converges. Ratio test, the limit of an plus 1 over an's got to be less than 1 for convergence. Comparison, you need to show something bigger than it converges. And limit comparison, you have to show that the limit is finite and non-zero.